everyone for this presentation. Today we will be looking friction, numerical problem on motion of connected body on plane and rope and pulley system. In last class we have discussed motion of single body on a flat and inclined plane. So today we will be looking another two type of problem under friction. Yes, first let us look into the connected bodies. What in case if two bodies are connected and both are being pulled? What happens in between this object? So you will be having multiple number of friction. So friction occurs in between the bodies. So if there is a flat surface and an object, in between this two objects you will be having a friction. And what happens if two object is there or multiple object is connected and every object has a friction? So what will be the case? How we shall analyze? So it shall be either connected one above the other, or one object can be connected with other object by using a cable or a strut. So let us solve this problem and understand the friction. Now the first problem, a block weighing 4500 Newton. So this is the larger block. This is having 4500 Newton, resting on a horizontal surface, supports another block of 3000 Newton as shown in figure. So the figure is given in the problem. Bottom you have 4500 Newton and at the top you have 3000 Newton. Okay. Find the horizontal force P required to just move the block to the left. So you have to apply a force. What you want to make is, we want to just move this object. We understood that by solving the earlier problem, sufficient amount of force which is being carried by the friction in between the object. If this is a 4500 Newton of an object, if you want to keep the object in rest or if you want to move the object, it will not happen in 1 or 2 kilonewton. It will be in a considerable quantity with respect to the amount of friction, amount of load and the way it's connected. Let us try to understand in this problem. They have given a component, that is, take the friction coefficient of all contact surface as 0.3. So what are the points you have contact surfaces? This is the point 1, and between A and B block you have a second point of contact surface. So you will be having two number of friction, and hence you can see that you will be having two number of friction. 0.3 N1. What is friction? Friction is mu into N. That is normal. N is normal and this is support reaction. That is mu into N. So mu here which is given as 0.3 and N we will be taking it as N1. For the second surface we will be taking it as 0.3. Why? Because for all the contact surfaces the friction is given as 0.3. So since we apply the force at left hand side, we know that the friction will be acting at right hand side. So at both the points wherever you have the surface contact, you should apply the friction opposite to the direction of motion. So since for this object we have found this. For the second object, if the object is pulled, that is the bottom part of the object is pulled and the top portion, that is block A, is not going to move, only block B is going to move. And what happens, due to the force, the block B is going to move to the left hand side and block A will be there, and we have a force, that is T, as the tension here which is being applied. The force is at right hand side, hence for the block A the friction will be at left hand side. So this block is not going to move right hand side. Wherever the object moves and the surface which is connected to the object will be having the opposite direction of friction. So at the block A, this object is not going to move at the right hand side. So it is handling with a force of tension T at the right hand side. Hence the friction will be opposite for the block A. The block B has two contact surfaces, that is the bottom and the top. Hence, you will be having two number of friction, that is N1 and N2. And the second block will be having only one friction surface, and this block carries a force which is acting at right hand side, hence the friction will be acting at left hand side. So this is taken as N2. So both the reaction will be same. This block will be supported by N1 and the other block will be supported by N2. Okay, take the first block, that is block A, and if you take block A here, the block A has a self weight of 3000 Newton. So the self weight will be acting downward, 3000 Newton is written here, and you will be having a support reaction, that is N2, which will be acting at upward direction. And since the force which is acting at right hand side, this is the tension, and it has an angle of 30 degree, and we can understand that the friction will be opposite, that is if the normal is N2, you will be having friction of mu into N2, that is mu here is given as 0.3, this 0.3 N2. So now we got the free body diagram, and we can resolve it horizontally as well as vertically. First, let us resolve vertically. Sum of f of y equal to 0. So at downward direction you have 3000, so minus 3000, and at upward direction you have N2, so N2 is written here as plus, and there is a tensile force which is at an angle of 30 degree, so sin 30, if you resolve it will go into the upward direction, and plus t into sin 30 equals 0. So now you can find the N2. Take everything outside of this equation, 3000 minus 0.5 t. So this will be one equation. Okay. Now let us resolve all the forces horizontally, and t into cos 30, which will be plus, so t cos 30 which will be plus, and the another horizontal component is minus 0.3 into N2. So minus 0.3 is written here. We know the N2 value as this equation. So instead of N2 we can substitute 3000 minus 0.5 t. The equation you have only one unknown, that is t. If you multiply this and simplify, you will be getting t as 885.827 Newton. So the tension applied here is 885.827 Newton, and if you want to find the N2, you can substitute the t value in this equation. Now the N2 we found as 2557.086 Newton. We have solved the free body diagram and the unknown for the block A. Now we know the value of N2 and the force, that is the tensile force. Now let us take the next free body diagram of B. Yes, now we are taking the block B. We know that the block B has two surfaces, that is 0.3 N1 and 0.3 N2. So the two friction is written here. 0.3 N1, we know 0.3 N2 as we have identified earlier, that is 2557.086 Newton. Yes, and you have a normal, that is a support reaction which is N1 here. So now we know the block B self weight, which is 4500 Newton, which is given here. The normal reaction, that is N2. See, this block has two number of support. One support is from the floor, that is N1, and the other support is from the block A. So this will be acting downward, that is N2. So we know the N2 as 2557, and it is written at downward direction. Okay, now the free body diagram is over. So we have considered all the forces. Now you can think that what about the block A self weight? Either it is not going to take here. So we have converted into the reaction. So this support we have converted into the normal force. So that is the block A is being converted into N2, and the N2 force is written here. So you can see that the block A has 3000 Newton of self weight. So we have converted the self weight into the normal reaction, Hence, we no need to calculate the self weight. Also, the frictional component of block A is also been applied here. That is N2 we have found out, and N2 into the frictional component. So both the components of block A is being taken here. That is the support reaction and the friction. Hence, you no need to worry about the self weight of block A, and only block B self weight is written here. Okay, after writing this free body diagram, so this object is being pulled at the left hand side. So P is applied at left hand side, and let us resolve vertically. N1 which is upward, that is taken as plus, and 4500 is downward. All the forces will be equal to 0. So if you take the negative terms outside this equation, you will be getting plus here. So 4500 Newton, which is taken as minus before this equation, and if you take outside this equation, it will be plus. The same way 2557 is also considered, and after taking this outside this equation, you will be having it as plus, and the N1 value is being found out as 7057.086 Newton. Yes, after finding the N1, the first unknown is being found, and the second unknown, that is P. If you resolve it horizontally, P is acting at left hand side, that is minus P, and at right hand side 0.3 into 2557, that is plus 0.3 into this value, and another value is 0.3 into N1. So the N1 we have already found out, so 0.3 into N1, both in terms of plus. If you need P, you can take this outside, and if you multiply, you will be getting P as 2884. And if you apply the 2884 Newton, the object will just move. So we can see that the friction between the block B, that is N1, is the highest, nearly 2300 Newton will be there as the friction at N1, and at N2 we got nearly 800 Newton. That is friction at the B, that is between the block B and the surface, is the highest. Nearly, if you multiply 0.3 into the N1, so you will be getting 2400 of frictional force, and at the top of the object you will be having nearly 800 value. And we can understand that due to the block A's support reaction and the self weight, it has higher number of friction. So if some force is being applied at a block, and the bottom of the block, that is the last block which is carrying all the load, which is having the higher number of friction when compared to the top block. Yes. Let us go to the next problem. Now here you can see a connected body which is having a 10, which is connected with another block by using a tie here. If you apply any force, so this object moves along in series of connection. The 20 box also moves. It is supported at inclined angle of 50 degree, and you have a 10 degree of inclination for the tie or the strut. So the strut is having a 30 kilonewton of angle, and the body or the object which is being placed at 50 degree angle. So calculate the value of P which is required to cause the motion of the block shown in figure. So what you need to do is just move the object from the rest. So what is the force which is required is the question here, and you can take the coefficient of friction for all the surface as 0.2. So both are same surface, and the friction coefficient is given as, that is mu is given as 0.2. Now let us take each and every single object and draw the free body diagram. Now let us take the first free body diagram, that is B. And if you take B, which is placed at an inclined plane, and which is having an angle of 50 degree. So this 50 degree is written here and the object is placed. You have the self weight of 20 into 9.81. So 20 is the kg. If you multiply into 9.81, you will be getting the weight in terms of force. And we have converted in terms of force. Next thing is, this is the direction of movement, that is the x-axis. If you apply a force, so in the free body diagram, we know that the block B, which is being applied with the force P, and this force transfers into the block A, and it also transfers to the block B by using this strut. So we know that this strut is applying a force in right hand side direction. So hence we have applied the tensile force. So we don't know what is the force. Since the P, whatever might be the P, you will be having an angle with respect to the movement of block A. Hence we are not knowing the force. Hence we have taken it as T here. And if you have a two block which is aligned at a single line, so this force, due to the property of transmissibility, you will be having the same force. But due to this angle, we have to find the unknown force, which is T. Okay, we have applied a force at the block B. You will be having a support reaction, that is N, that is normal. So normal N1 is written here. Since it is the first block we are considering, we will be taking it as N1. So the direction of movement of the block will be upward, and hence your friction will be downward. So friction is mu into N1. So mu here is given as 0.2 and 0.2 into N1 is taken. And we have written all the components. Next thing is, we have to identify the angle with respect to the movement of motion. So we know the movement of the motion will be along the x-axis. So we have to identify the angle also with respect to x-axis in order to go to the solution. So what will be the remaining equation? What you can do is, you can draw a horizontal line. We know that in a straight line, if you draw a horizontal line at any point, you will be having the same 50 degree angle. So the rest of the angle will be 40. So 40 plus 50 will be 90 degree. We know that this vertical force will be at an angle of 90 degree, that is, which will be in perpendicular to this reference line, and we know this as 50 degree. Hence we found out the remaining angle, that is with respect to the x-axis, as 40 degree. Okay, now we have this tensile force. We should identify the angle along with the movement of the motion. Yes, if we want to find that, we know that the opposite angle will also be equal. So if the angle which is given as 30 degree here, if you draw a horizontal line, the opposite angle of this line will be the same angle. So you will be having a 30 degree. Hence we have written this as the 30 degree. Okay. We know that this is a straight line. This is the line of motion, and this angle is 50 degree. So since this is 50 degree, the opposite of this line will also be 50 degree, and we know the tensile force which is acting at an angle of 30 degree with the reference horizontal line, and if you subtract 50 minus 30, you will be getting 20 degree angle. So this 20 degree angle is with respect to the x-axis. Now you can see that this 20 degree angle which will be used in the resolution. If you find the angle with respect to the line of motion, it is very much easy in order to get the solution. So you can take many ways to find the angle. So it is the best way to take the angle with respect to the motion. So our motion will be in the direction of the x-axis. So we have found out the angle with respect to x-axis, that is 40 degree, and the another force also with respect to the x-axis is 20 degree. Now all the forces are written here and the angle is also written. Let us take the resolution of force, that is summation of f of y equal to 0. So we are resolving all the forces vertically, that is at the y-axis. So 20 into 9.81, if you resolve into y-axis, minus 20 into 9.81 into sine 40 degree. So if you resolve this, it will be going in downward direction. The other force which is acting at upward direction, which is N1, and it is taken as plus N1, you have a tensile force. So this is T, unknown force. If you resolve this, it will be acting in downward direction, that is T into sine 20. So minus T into sine 20. So if you take this outside this equation in order to find N1, so the N1 will be 126.115 plus 0.342 T. Let us keep this N1 here and let us move to the next step, that is summation of f of x equal to 0. Now we are resolving all the forces with respect to x-axis, and if you resolve that, you have a friction which is acting in negative direction, this is left hand side, and minus 0.2 into N1. So N1 we already know, hence minus 0.2 into this N1 value we have applied here. And the right hand side you have tensile force which is T, it is at an angle of 20 degrees, so T into cos 20 degree, so plus T into cos 20 degrees written here, and the last force is 20 into 9.81. If you resolve with respect to x-axis, you will be multiplying with cos 40 degree, so minus 20 into 9.81 cos 40. If you simplify, the only one unknown is T here, so you can simplify and find T as 201.609 Newton. And if the object has to move in upward direction, the tensile force T required is 201 Newton. Yes. Let us next find the free body diagram of block A. Drawing the free body diagram of the object A, you have a self weight which is 10 kg, so 10 into 9.81 which will be acting downward, and a force P which is acting at right hand side, and we have written here you will be having a support at the surface, so it is taken as N2. Since we have taken this as N1, we will be taking the another support as N2. And if the motion is right hand side, the friction will be acting at opposite direction. Hence, it is taken at left hand side, and it is mu is given as 0.2 in the given data and mu times N2. So this will be the friction. And what happens? This object is being applied with the tie. So this tie applies a compressive force, that is, this object always try to push the block A. So hence the tensile force is written as left hand side, and it is at an angle of 30 degree which is given here. And for the previous free body diagram, the block B is applied with the upward force, since the object always provides a upward force by using this strut, and for the block A, the block B tries to compress the object. So hence it is acting towards the object. So T is written here, and let us apply the summation of f of y equal to 0. So we are resolving all the forces with respect to y-axis, and this will be minus 10 into 9.81 Newton which will be acting downward. So minus 10 into 9.81. So upward you have N2, so plus N2, and you have a T force here. If you resolve T into sine 30, which will be minus. So T we have already found out as 201.609 into sine 30, which will be minus here, and N2 is found as 198.825 Newton. And if you resolve it horizontally, summation of f of x equal to 0, you can take it as minus 0.2 into N2. So N2 we already know, minus 0.2 into N2 is written here, and plus P, it is acting at right hand side, so plus P, and T into cos 30 which will be acting at left hand side. So T into cos 30, which is left hand side. The only one unknown is P here. If you take it outside this equation, you will be getting P as 214.364 Newton. Now if you apply 214.364 Newton force, this object moves the block A and block B. And how much of force is being transferred in between block A and block B, which is the strut or the tie, which carries a force of 201.609 of force. So we have identified the unknown forces and the friction between the two surfaces. These are the hidden parts. So if something has to happen in this real world, complement of the things which are acting in this object, which are friction and the support reaction, which will be found out by using this theorem. It is very interesting to know the rest of the components. Yes, next system is rope and pulley system. Before this, we have discussed connected bodies. If two bodies are connected by using a strut, and what will be its friction and what will be its components of motion. Now, a rope and pulley is used in practical application in day-to-day life and in many manufacturing industries, and the companies like Amazon and those who are transferring the object in the warehouse from one place to another. Earlier, they used to do a rope and pulley system. They can hang easily object to any height or to any distance by using this rope and pulley system. Also, the backdrops and the screens which are operated by using the rope and pulley system. So you will be having a pulleys at each and every direction where you need to move the object. So you will be having the rollers here, and if you hang any weight, it might be a screen or it might be a weight. So if you move the rope, what will happen? The pulley transfers your weight and it reduces the self weight of the object. That is, with less effort you can make the work done. And there are different types of connection of the pulleys. You can see that if these are the different types of pulley connection. So this is gun tackle and luff or watch tackle. You can see this different types of tackles. So a pulley is being connected by the rope. If you have a single rope connection and if you pull this object, and if a double tackle technique is used, there are two major ropes which is carrying the force, and what happens, the effort is very much less when compared to the gun tackle method. And if you take the threefold purchase, if you apply 1/3 of force, which is enough to hang the object. So this is the explanation of this. Say for example, if this is weight W, it is being hanged in a pulley, and you have two number of pulleys here, and if you apply, if this might be 100 kg of weight, so if you apply only 50 kg of weight, which is enough to take the load and which is enough to lift the load, so the effort is very much less here. So if you apply 4 number of pulleys and if you hang a weight of W here, what happens, due to the 4 number of action, the total weight, if this is 100 kg of weight, if you apply only 25 kg of weight, you can be able to lift the 100 kilo of weight. So these are the different ways or methods of reducing the weight. So the rope and pulley system makes our work less, our effort less. So you can apply less effort in order to take the maximum weight. So this is an example of how much of force is being lifted here, and you can see if you want to lift a 100 Newton of a dead weight object, 50 Newton and 50 Newton of force will be applied at each and every rope. So finally it will be 100 Newton. So if it is downward 100 Newton is acting, we know that by equilibrium equation 100 kilonewton of force which is required in order to keep this object in a stable. So it is being shared by two ropes, and finally the 50 kilonewton of force which is only been transferred by this technique. So if you apply force which is enough to take care of the 100 Newton of force. So the support will be taking 150 Newton here. Yes. So let us use some of the problem in order to understand this concept. So how much of force either which is required to make our job easy. So you can create, so you can make your own mechanism. So what is the weight you are going to carry, and according to that you can use the rope and pulley system in order to make your effort easily. If you are dragging the water from the well, it is the mechanism of rope and pulley system. So the bottom bucket carries a water weight and you are applying a tensile force, so you are getting the water. If you want to lift more water, you can try these type of technique and this number of pulleys in order to drag the weight easily. One or two problems in this title in order to find the mechanism of friction and other forces to apply in your real life. And let us take a block weight of 6 kilonewton. So this block has 6 kilonewton weight which is attached to a string. So this is attached to a string which passes over a frictionless pulley. So this pulley doesn't have any friction, that is zero friction, which is also called as smooth, and supports a weight of 3 kilonewton. This string carries a weight of 3 kilonewton when the coefficient of friction between the block and the floor is 0.35. So this block is being placed in a floor and the surface friction is given as 0.35, and determine the value of force P when. So you have to find the force P. The motion is impending towards the right. So if you want to move the object right hand side and if you want to move the object towards the left hand side. So for both the cases, what is the force which is required? Drag the 3 kilonewton downward, you can push this object to right hand side, and if you want to lift the 3 kilonewton, you have to pull this block to the left hand side. So what is the force required in order to operate this mechanics? So whenever a body is hanging in free air, there is no need to consider the normal reaction. So there are two blocks here. So you would be wondering that if there is a self weight, you will be having a normal reaction. So since you don't have any support here, that is any floor here, it is hanging in the air. So you will be not having any normal reaction. So this 3 kilonewton block can be taken as this, and downward force of 3 kilonewton will be acting due to its self weight, and upward force, which is the tension which is acting, you can take this. So since the pulley has no friction, so there will be no friction will be acting in this mechanism. And if you resolve it vertically, you will be having minus 3 kilonewton and plus T. So if you need T, T will be 3 kilonewton. So this tensile force which is there applied in the string is 3 kilonewton. Yes, we have found out that, and this string is being transferring the force to the larger block. So we have found out the T as 3 kilonewton. Now let us draw the free body diagram of the larger block. Now we have two conditions, that is if you move the object left hand side and if you move the object right hand side. So this object is in equilibrium. So let us try to move this object at left hand side. What is the force which is required if you need to pull this object? And if the force is acting at left hand side, definitely the friction will be at right hand side, and which will be mu times n. So mu here is 0.35 and n, and this object will be having normal reaction and a self weight. So both are written here. So if you resolve in y axis, 3 into sine 30 degree. This is the tensile force. If you resolve this, sine 30 degree, which will go in terms of upward direction, so plus, and minus 6 kilonewton is applying at downward direction, and you have n at upward So plus n equal to 0. So if you resolve this, you will be getting n equal to 4.5 kilonewton. And if you resolve this in terms of x-axis, you are having minus p and plus cos 30 degree. So plus cos 30 degree into the P value, which is tension, and 3 into cos 30. And the direction of friction will be at right hand side, so plus 0.35 into n. So n we have found out as 4.5. If you multiply and simplify this, you will be getting 4.19 kilonewton. And if you apply 4.19 kilonewton, the object will move in the left hand side direction. If you want to move the object in right hand side direction, you can apply the force at P at right hand side and the friction will be acting at left hand side. So if you resolve this, the remaining component are same, and if you push or pull this object, so you can try to push or pull, always the force will be acting at the right hand side. Why? Because this is a tension, this is always going to act at the right hand side direction. So it is acting at P equal to 3 kilonewton. So if you resolve it in terms of y-axis, minus 6 kilonewton plus 3 into sin 30, minus 6, 3 into sin 30 plus n. So the n value will be the same, which is 4.5 kilonewton. And if you resolve this in terms of x-axis, plus p and minus 0.35 into n. So plus p minus mu into n, that is 0.35 into n, and plus 3 into cos 30, plus 3 into cos 30. If you resolve this, you will be getting p equal to 1.04 kilonewton. So if you apply the force of 1.04 kilonewton, this object will move at right hand side direction, and the force which are given here. So if you are not giving any force, this object is said to be as in static, and it is said to be in terms of rest here. Yes. Now let us take the next problem. Calculate the value of W which is required in figure. And this is the object, which is 1000 Newton. This is at an angle of 20 degree, and here is a pulley and a weight is being hung by using a rope to cause the body to move in upward direction and to cause the body to move in downward direction. So what is the force which is required to move the object in up and down? So you have to apply the force left hand side and right hand side in order to move this object, and you are having a friction coefficient of 0.3 which is given here. Let us find that. So we know that the tensile force will be acting T. This will be the same as the value W. So whatever force you give in tension, why? Because the pulley has a smooth surface that is frictionless, hence it will be the same. You can refer the previous problem, and if you want to move the object upward direction, so you can give a direction of T here, and this will be the x, and the perpendicular to this will be y axis. So next you have a self weight of 1000 Newton. This 1000 Newton is acting at an angle of 70 degree. How we have found out the angle with respect to this is, you can see this line is at an angle of 20 degree, and from the horizontal line it will be at 20 degree. So the remaining angle will be 70 degree. And we have found the angle with respect to the direction of motion, that is at x-axis. If the object moves at upward direction, you will be having the friction at downward, which is 0.3 into n. So let us resolve vertically. So minus 1000 into sin 70 degree. It will be acting downward, and you have a reaction, that is n is upward. So you can find the n as 939. And if you resolve in horizontal axis, and 1000 into cos 70 degree, so it will be acting at left hand side direction, that is minus, and you have a right hand side force which is T, that is plus. If you simplify this, you will be getting T equal to 623.928 Newton. So weight and tension both are equal, and if you apply a force of 623, this object will move upward direction. So if the object wants to move at downward direction, what you have to do is you have to apply a force which is acting downward. So you have to pull this object in order to make this object move into downward direction. Let us keep this as negative direction, and perpendicular to that will be the y-axis. So this will be x and y-axis. We know the components, the rest of the component is 70 degree. And if you resolve in terms of vertical, that is in y-axis, you will be getting 1000 into sine 70 equal to n. So the n is acting upward, that is plus. So if you take it outside this equation, you will be getting n as 939.698. The reaction will not change. And the horizontal force, that is sum of f of x equal to 0, we are having a left side force which is minus t, and since we need to drag this object downward, we have made this as left hand side and minus t. So the friction will be acting at right hand side, that is 0.3 into n. So 0.3 into n, which will be plus, and if you resolve 1000 Newton into cos 70 degree, 1000 into cos 70, which will be acting at a negative, which is acting at left hand side, and it will be equal to 0. So you know n as 939.693. So if you substitute this, you will be getting the value of t. Here w and t are same. If the w value is 60.112, if you apply a 60.112 Newton, what happens? This object goes downward. So if you apply a weight of 623.928, so if this weight is 623, then the object is dragged upward. So these are the two range of values, that is 623 and 60.112. So nearly 10 times of force which is being taken by this friction and this angle of the body. So this body is placed at an angle and which is having a self weight of 1000 Newton. So these three factors have 10 times the effort. So you need 10 times effort in order to drag this object downward. So I hope that the mechanism of rope and pulley action as well as the connected body, so we have discussed here, and if you apply for many number of cases and if we work out, we will be getting further understanding in this topic. World around us consists of mechanism, and we can easily predict what is happening around, what are the forces behind that, due to what force which something is moving in this universe. I hope that this session would have given you some knowledge regarding this topic. See you soon. Happy learning.